Mathematics Grade 6 First Term 2024 Unit 2 Lesson 4 Comparing and Ordering Rational Number Explanation Part Number 2 Example number 2 Compare the two numbers in each of the following using the suitable sign less than, greater than, or equal. Let's start. Point A 5 over 12 and 7 over 12. Here we have two like denominator 12 and 12. So 7 is greater than 5. So point A, I can say that 7 over 12 is greater than 5 over 12. Okay. B, it's 1 over 4 and negative 5 over 6. Of course, positive is greater than negative. So B, any positive is greater than any negative rational number. Okay. C, 11 over 12, 11 over 15. It's the same numerator or like a numerator. So the smallest one is the biggest or the greatest. So 11 over 12. So C, 11 over 12 is greater than 11 over 15. Okay. D, 6 over 12 and 2 over 3. Here we have no positive and negative. There is no like denominator or like numerator. So we need to find out like denominator. Look here, D. We have 6 over 12 and 2 over 3. Just we note that 12 is a multiple of 3. Okay, so 6 over 12 constant, the same, and we need to convert 2 over 3 to be like a denominator 12 as is 12. Okay, how to convert 3 to 12? Times 4. So 2 times 4 equal 8. Now I can compare these two fractions with like a denominator 12. So 6 over 12 is less than 8 over 12. Right? So we can deduce that 6 over 12 is less than 8 over 12. It's 2 over 3. Okay. 3.2, 11 over 2. How to compare decimal with a fraction? Note that this decimal 3.2 is greater than 3. 11 over 2. 11 over 2, it's not proper, it's improper fraction. So we can convert it to a mixed number. 11 over 2, it's equal 10 plus 1 over 2. It's equal 10 over 2 equal 5. And 1 over 2 is a fraction. So this becomes 3.2 and 5 and half. Of course, 5 and half is greater than 3.2. Okay? It's easy. So point E, I can deduce that 3.2 less than 11 over 2. Okay. Point F, 2 over 3 and 4 over 5. We have here, there is no like a denominator or like a numerator, 3 and 5. To find out the log common multiple between 3 and 5. We know that 3 and 5 is a prime factor, a prime number, sorry. Okay, to find out the log common multiple of these two numbers, we need to multiply them. 3 times 5 is equal 15. So we convert them. 3 times 5 equal 15. 2 times 5 equal 10. 5 times 3 equal 15. 4 times 3 equal 12. Now it's obvious that 12 is greater than 10 with like a denominator 15, right? Okay, so point F, it will be that 12 it's comes from 4, so 4 over 5 greater than 2 over 3. Point G, 3.7, 3.15. Oh, this two decimal number, look here, we have 3 whole number, point and point, 7/10 and 1/10, 5 hundredths and 0 hundredths, right? I can put 0 to the right of any decimal number just after the point. Okay, so 3.17 hundredths, 3.15 hundredths. Of course, 3.17 hundredths is greater than 3.15 hundredths. So point G, I can tell that 3.7 is greater than 3.15. Just 7/10 and just 1/10. Or I can say that it's 17 hundredths, 70 hundredths, and 15 hundredths. Last point H, -4 and -4.1. Oh, it's two negative number. So note that if we have 4 and 4.1, of course 4.1 is greater than 4. But when we put -4 and -4.1, now it's the opposite. -4 is greater than -4.1 because -4 is to the right of -4.1. It's if we have positive sign or we have negative sign. Okay, don't forget that number line. Okay, if we move this way, it's from the smallest to the greatest. But if we move this way, it's from the greatest to the smallest. Okay, so 4 here and 4.1, -4, -4.1. Look, 4 smaller than 4.1, but -4.1 is smaller than -4. Example number 3. Arrange the following rational number ascendingly. Ascendingly, it means that to start from the smallest to the greatest one. Okay? Okay. Look here. -2 over 3, 3 over 4, -7 over 12, 5 over 6, and finally -1. Okay? Okay. Ascendingly, it means smallest to greatest. Which one is the smallest? Oh, I can indicate which one is the smallest or the greatest. Okay? So, if we have some number, some rational number like that, I can't compare them directly. How can I compare them or order them to make it all as a picture of A over B? All of them in this picture, on this form. Okay, I have -2 over 3, it's A over B. 3 over 4, it's A over B. -7 over 12, it's A over B. 5 over 6, it's A over B. -1 over 1. Okay, any integer, its denominator will be just 1. Any integer, its denominator 1. Okay? Okay. Now I cannot arrange them. So how we can find out the correct way to make it the same denominator we have here 1, 6, 12, and 4, and 3. You may note that 12 is the biggest denominator. Look, 12 is multiple of 4. Why? Because 3 times 4 equal 12. 12 is multiple of 3. Why? Because 3 times 4 equal 12. 12 is multiple of 6 because 6 times 2 equal 12. 12 is multiple of 1 because 1 times 12 equal 12. So we can deduce that 12 is multiple of all the denominator. So I can convert all these fraction a over b to a fraction with like denominator 12. Negative 1 over 1, negative 12 over 12. Why? Because 12 over 12 equal 1 and with the negative sign. Okay, 6 becomes 12. How? 2 times 8 times 2. Okay, but 5 times 2 equal 10. Okay, 12 is the same itself, 12, so negative 7 will not change. 4 becomes 12 by times 8 by 4 by 3. 4 times 3. 4 times 3 equal 12. 3 times 3 equal 9. 3 times 4 equal 12. 2 times 4 equal 8, and don't forget the negative sign. Now we have all fraction in the form of a over b with like denominator. Okay, I know that any negative will be smaller than any positive. Look here, negative and negative and negative. These three fractions is negative or negative rational number. Of course, this rational number is the smallest, is smaller than the positive rational number. Which one is the smaller than the other? Smaller than other? We can find out negative 8, negative 7, negative 12. Each negative, it's negative 12 is the biggest one. Why? Because the negative direction, the biggest one is a smaller one with the negative sign. So I can find out that negative 12 over 12 will be the smallest rational number. After that, negative 8 over 12, negative 7 over 12. Okay, because the negative sign, okay, if them are positive, this is the greatest one, so then and then. But because of the negative sign, I can't find that negative sign to find out that negative 12 is smaller than negative 8. Negative 8 is smaller than negative 7. That's okay. Now we have two positive fraction, 9 over 12 and 10 over 12. Because this number are positive, so 10 is bigger than or greater than 9. Okay, I need to start from the smallest, right? So I need to start with 9 over 12, then 10 over 12. But let's make them as the first picture, first form, that negative 12 over 12 is negative 1. 8 over 12, 8 over 12, it's come from negative 2 over 3, negative 7 over 12, negative 7 over 12 come out negative 7 over 12 itself, 9 over 12, 3 over 4, 10 over 12 from where? From 5 over 6. So this is the final arrange in ascending order. Now let's check our understanding. Complete each of the following using the suitable sign. Less than, greater than, or equal. Here we have 5 and 5, so 7 greater than 4. Negative and negative. Attention, negative and negative with the same denominator, so negative 2 is greater than negative 3. 1 over 5, 1 over 6. Here we have like it numerator, so 5 in denominator will make it greater than 6 in denominator. 3 over 6, 2 over 3. Note that 2 over 3 is fraction. Improper fraction in the simplest form, but 3 over 6 I can simplifying them. Over 3 equal 1, over 3 equal 2, right? Okay, so we have half or 2 over 3. Which one is the greatest or the smallest? I don't know. Another way, we have here 6 and we have here 3. I can convert 3 to 6 or what? Yeah, by times 8 by 2. 2 by 2 equal 4. Now we have like a denominator 6 and 4 is greater than 3. Here we have 4 over 10, 14 over 35. How can I figure out which one is the smallest or the greatest? Let's try. Can I convert 4 to 14? No, because 14 is not a multiple of 4. Can I convert 10 to 35? No. Why? Because I cannot convert 10 to 35. 10 times what equals 35? There is no way. So, how can I compare this to a fraction? By simplifying them. Note that 14 over 35, I can divide it by 7 equal 14 over 7 equal 2. 35 over 7 equal what? 5, because 5 times 7 equals 35. Now I can find that 2 over 5 and 4 over 10. Look with me. How to convert 5 to 10? By times 8 by 2. 5 times 2 equal 10. 2 times 2 equal 4. Wow. 4 over 10. 4 over 10. It's equal. Last one. We have 10 over 5, 15 and 2 over 3. Okay. We find that 15 is multiple of 3. Right? So I can convert 3 to 15 by times 8 by 5 by 5. 2 by 5 equal 10. 3 by 5 equal 15. You can find that it's equal to each other. Last question. Arrange in ascending order. What ascending? Yeah, from smallest to greatest, right? Okay, all these for rational number is positive. There is no negative. It's okay, but we have 4 unlike a denominator. I need them like a denominator. We can find out that 15 is multiple of the all of them. So we need to convert them. 15 and 15 here is this itself without any change. But I need to change 5 and 3. 5 to becomes 15 times what? Times 3. 2 times 3 equals 6. 3 times 5 equal 15. And 2 times 5 equal 10. Now I can easily arrange them from the smallest to the greatest. Which one is smallest? Note that it's all positive. So smallest numerator is the smallest one. Smallest numerator here 4 over 15. 4 over 15. Let's start with it. Next one 6 over 15. But note that it was 2 over 5 in the origin form. Okay, next 7 over 15. 7 over 15 itself. Last one 10 over 15, but it was 2 over 3, and this is the ascending order. And thank you, it's end of part number 2, and thank you.